This conference will now be recorded.
So what are those two things? One is Hadoop development and Hadoop administration. Two different learning modules were there. Hadoop are big data development and big data Hadoop administration. Okay, and whatever we are targeting, it is development. It is not administration. Administration means you should be a hardcore system admin first of all. Mostly, who will migrate to administration? Mostly, I'm telling, not 100%, but at least 90%. That 5 to 10% we can give that leverage to other people. Administration, people get into administration when you are a system admin already. You are a network engineer or you are something else related to the machines first. You who get into development then? Who are already working in some data warehouse, ETL processing, or who are working on data DBA, who are working as a DBA, or who are working as a programmer or a developer like Java developer, .NET developer, who are on mainframes, all different other areas, which is related to more of programming, less of system management. Such people choose what is that development. Got it right? Yeah. What about big data testing? Big data testing, see, anybody can try that. You have some testing knowledge and with some big data fundamentals, you can go for big data testing. That is okay, but that is a different area. Actually, I don't know what is this big data testing because we are doing lot of projects, but normal regular testers do the testing. Okay, the testing team will be there, which is from IBM actually. If you want, I can tell that as well. Who is our testing team? They were from IBM. They are exclusively they perform testing. Got it right? So the development team is from Virtusa and testing is from IBM. Support team is from Infosys and also CTS Cognizant. Okay, means whenever if it is a big account like one company doesn't involve into the project, they try to involve these people, these clients involve multiple companies are working on that. Even if you go to bank of no bank, any banks like Citibank or Bank of America or chartered account like so chartered bank, okay, all this I see many different very big service companies involving in doing that. Even if you look at Bank of America, they have Infosys, they have TCS, they have Wipro. All these accounts were there. All the service providers will be working with their projects. Point is here, what is that? Finally, the conclusion point is testing. Somebody asked me about testing. I'm telling you this. See, big data testing in sense, you should be a hardcore tester for that. There might be some experience on some understanding, like whenever we do some loading of data, or whenever usually what big data does, what exactly big data does. Do you have any idea, folks? The purpose of big data is usually we keep the data ready for the other people. Like for us, if you take an example of us, because somebody asked me about big data testing, I'm just trying to explain quickly. What we do is we prepare from very core level. We are working at very core level. Our responsibilities are mapping that data in the HBase, and we have some document kind of stuff there. Okay, then we try to what is that load data into the HBase by doing some mapping, and as well as we get some data files and then we try to load it into the HBase. That's what we do. You got it right. Then the point is testing. Once we do, whether this loading is successful or not, there will be testers who will be doing all this. For that, you don't need to have any prior knowledge for big data. So minimum understanding of what they do is you have all the credentials given, the data loaded, all that. You have to just quickly check what is loaded and all that. For that, hardly if you have a week of experience on that, automatically you can just take it forward. But you don't need to be any what is that serious big data, because if you are really having big data knowledge, you will work as a developer, right? Why do you go for testing? You got the point, right? So that's it. Clear now? I think Babu is the person who asked me. So for that, you should be a hardcore tester. That is fine. That is enough. So you can get all this quickly. You can upskill yourself once you start a week or two into that big data environment. So finally, the point is that when you have two different modules like this, we are working on development. Usually, development people, they are not hardcore administrators. They have whatever that is fundamentals necessary to understand big data. Okay, that we learn actually in this development process. And if you are going little deeper into that administration part, I think developers are not that. What is that? They are not that expertised at admin part. Okay, so they get some no basic level understanding which is necessary to work in a big data development. So keep it right. So whenever whatever I am trying to explain to you, point I would like to make clear is that it is whatever that is necessary for a big data developer that I will discuss. And if you are going deep into the administration part, means see, point is I'm not sure like 100% I'm not an administrator. So there is a what is that? If it is clear, really necessary for a developer, we can take it deeper into that discussion. Otherwise, what you can do is you can check it so with your existing, some friends in the company or had Hadoop administrators in the company. That's all. Okay. But we cannot go too deeper into the administration part. If anybody wishes to get into that, either take somebody's help after the session so that you get the very basic level and clear understanding about fundamental things. Later on, you can ask your friends. That is one thing I would like to clear in the beginning itself. But when it comes to development part, definitely we can go how much our depth you want. Okay, and that's it about this one development part. Now, I'm just making clear. Somebody is asking me about testing. I have explained that. Then the point is which module we are targeting. We are targeting development. We are not targeting administration. And whatever that is necessary, we learn here to understand the dynamics of big data development, not the administration. Okay. So next one. Yesterday we have seen the limitations of Hadoop1x. That is one thing. Second thing is we need to understand differences between what else. What is the difference between Hadoop1x and 2x? Okay, that we should understand. So one basic difference is if you look at this diagram, I'll just show you now. So one fundamental difference between 1x and 2x is not this one. I'll just show. This one, if you see here, already you have a clear idea about Hadoop1x. So I think now in the industry people are not using 1x. Mostly 1x is outdated. 99%, at least 90 to 95%, 1x is not available. Most of the projects are running on 2x, and 3x is the latest development. We are not we cannot guarantee that people have started working on 3x, but very few people might be doing that. Okay, usually it will take time. Whenever something was introduced into market, for companies to adapt to that new environment, it will take at least there will be 2 to 3 years gap. Got it right? So now 1x, it has the HDFS that doesn't change anywhere. So the layers are same for both Hadoop 1x. That storage environment is same. The core ecosystem doesn't change. All others doesn't change. What is that? The pig or hive or Uji, those services don't change. What changes is the processing engine. So what is that processing engine? We have MapReduce. So our processing engine is MapReduce in 1x. But in 2x, there are many other processing engines were involved. Like Spark is one of the major path-breaking innovation. Addition to the Hadoop cluster, of course, Spark is a different. When you say big data has the core processing engine as MapReduce. Now, What else? In 2x, they have introduced yarn. This is also part of Hadoop itself. But Spark is used for what is that? Instead of that is also one more processing engine. No, again, yarn will be there on top of all this yarn and HDFS. The Spark everything will be running. Okay. Now, so you can also integrate Tej, or also there are so many new execution engines which you can integrate with Hadoop 2x. Okay, nowadays Hadoop 3x is supporting even Microsoft tools as well. Okay, if you talk about Azure, earlier 2x doesn't support Microsoft tools. Okay, integration of Microsoft. Now Hadoop 3x is supporting. It is supporting the integration for Azure, Microsoft Azure, and other different tools related to Microsoft. Even this Hadoop supports cloud, the cloud tools as well, like AWS. We can also move this Hadoop cluster to clouds. For that, there should be some libraries available, should be there. Cloudera people are providing all that, nothing to worry. So the major difference here is between 1x and 2x is we have MapReduce is 1x and you have yarn in 2x. That is one difference. And also earlier, it was MapReduce which is doing all this analysis and processing. Now Spark has almost replaced that. Yarn is there, HDFS is there, but still for doing this processing and for doing this analysis, data analysis, now Spark execution engines are used nowadays. Okay, that is again a separate big data framework like Hadoop. What they does is they actually that is 100% faster than this MapReduce. That's why it's a huge hit in the industry nowadays. Nobody talks about MapReduce in the interview. If at all, if that guy is talking, means either he doesn't know Spark or he is almost a legacy fellow. Okay, means he's an outdated interviewer for you. Trust me. And second thing is mostly many things which we learn here. Nobody talks about HDFS nowadays. Earlier, at least people used to ask questions. Okay, whenever interview starts, they talk more on Spark and Scala and all that stuff. Okay, Kafka and all these were different areas which people target. So finally, this is the major differences. Other than this, other ecosystems like we'll talk on all this again. I will explain about what is big and today we will discuss about ecosystems as well. At least, at least a popular ecosystems, if not every ecosystem, because it's not that necessary. So that is difference. What is difference between MapReduce 1.x and 2.x here? In 1.x, the execution engine is MapReduce, whereas in 2.x, the execution engine is yarn. Then what is the major difference? So you don't need to discuss too much of this. Just basic understanding is more than, because mostly in interviews, people don't ask questions on yarn. Even if they were asking, just you can tell a quick difference because you are not an administrator to talk too much on this kind of execution engines. You can tell that this is your area, you are working on this area, and your limitation is this. And you can, if you are really working on something, you can tell them with much confidence. We never see all these services, a MapReduce or yarn. But only thing is when we run in the background, they keep running out until that level, we have a clear idea. But how this MapReduce is performing or how this yarn is performing is not something which we need to focus. We have so many other development activities. So we have to take care of that. So that we look into that. So you can tell to the interviewer, okay, you ask certain things what I am working, not on administration. You can clearly tell him in the beginning of interview itself. If he is just going deeper into the administration part. So one thing about yarn is, what is an yarn here? So the major difference between Hadoop 1x, of course, there are other differences. Hadoop 1x and Hadoop 2x is so one is there is a lot of change in the processing engine. Here earlier we used MapReduce in 1x. Now we are in 2x. We are using yarn. What is yarn here? Yet another resource negotiator. What is that? Yet another resource negotiator. You remember, right? Do you remember? Yesterday, in the limitations of 1.x, we discussed one point. What is that pointer? Here, the job tracker is overloaded because it is performing two things. Okay, this job tracker and task tracker are part of MapReduce only. You know, we have three services, right? What are those three services? Services are like this. What is that? If it is HDFS, you have name node, then you have data node, and then secondary name. Whereas if you talk about MapReduce, of course, even though we show all those as part of HDFS, this job tracker and task tracker, these are part of MapReduce processing. And when you talk about it, your job tracker is getting overloaded, right? Why it is overloaded? Because both scheduling and resource allocation is done by job tracker. And because of that, what happens? Job tracker is overloaded. Understood? But in Yarn, there are different services. Again, Yarn itself is a very big service. It's a processing engine. And in that, for taking care of resource management, there is a resource manager. There is a separate service called resource manager. So that is one thing. And here we have a resource manager. And for taking up for scheduling, there is something called scheduler. And also for allocating resources and for executing certain things, there is something called application master. There is one more. So these are the three core services of Yarn. Like, I'm not going too deeper into this, but just a quick understanding. You don't need all this. Earlier, I tried to understand too much, but later on, I realized this much is not necessary for a developer. Trust me. Okay, all this bullshit is nonsense. Just understand what is necessary for it, because we are not a administrator. Again, I am emphasizing on this point. So here, I told you, right? There are a couple of things. What is that? Application. If you look at this, the core resources are resource manager and then scheduler, application master. These are the three core resources of Yarn. I will explain. I'm not going to just quickly take it. You can see here. RM. This is a simple architecture. Look at it. You have a resource manager which negotiate resources with all the application masters. Earlier we have HDFS, right? In that we have the task tracker and job tracker. You remember, right? Now your job tracker is almost has all these services. In a way, if you talk from that comparison levels, okay, job tracker means okay, right? Somebody is asking me some questions here. How can we differ Kafka and big data? The Kafka is a streaming. It's a streaming tool, Koteshwara. This is not time to talk about has Kafka. I'll explain about all ecosystems. While explaining, you can ask this question, sir. Okay, got it right? Hadoop 1.x don't have any streaming support. We can integrate Kafka with Hadoop. We can integrate Spark with Hadoop. We can integrate other tools with Hadoop. That is there. Okay. And somebody is asking, Kafka is different one. Exactly. Kafka, the responsibility of Kafka is to take, it's like a message broker, okay, who is taking care of, exactly like producer, yes, Guru, it is like a producer and, yes, exactly, MQ. It's like producer and consumer only. In Kafka, there will be two services, producer service and consumer service, Kafka producers and Kafka consumers. That's a simple topic. It's not that complicated. It's more like, you look, it's like more like an admin kind of concept. The purpose of Kafka is streaming. We'll talk on that. I will explain ecosystem. Let me finish this first. Here, what is that? Now we have different services. Resource manager takes care of RM means resource manager takes care of resource management. Scheduler takes care of scheduling. And application master manager takes care of all the application masters. And earlier we have task trackers. Now we don't have task trackers. We have node managers. What do we have here? What do we have? What do we have? Node managers. We have node manager, no task trackers. Do you have job tracker now? There is no job tracker. We have resource manager, or we have scheduler, we have application manager. Means the architecture is completely changed in one Hadoop 2x. Okay, there is a separate service for every responsibility. Earlier we don't have that. And you can see, same concept. Again, node managers will use heartbeats. Okay, the process is almost same, but you don't need to get that too much into that. Just get some basic idea. So now we will quickly just get to the discussion now. If you want to have a quick idea, I'll just show you yarn architecture. You can see this now. This is I think this should be an official document. This is from Apache Hadoop actually. You can see this diagram. I'm maximizing this. Let's see this now. Can you see this now? Like yesterday, we have HDFS architecture. And this is our Apache website. Okay. This is our client edge node. If you look at this, whenever we say client here, these are all edge nodes. Again, also you can assume them as from edge node, there is a command line, right? We can also call it as a client. From command line, you try to connect it to HBase, you try to connect it to Hive, you try to connect it to Pick, you try to connect it to Spark, you try to connect it to many things. Are you following? And if you look at this, here they are just showing what resource manager. And again, app master here inside the other box. These are all slaves. This is master service. Okay. And name node, data node, they are there. They don't change, guys. They are not name node, data node, secondary name node. Still, that part is same. That is because HDFS doesn't change. What changes is map reduce changes. Well, map reduce changes. Then what is that? What is the change in that? So the transition here is simple. We don't have job tracker, task tracker. We have resource manager. We have app master. We have node manager. Node manager is one. Let's take this like task tracker. Containers means like these are like yesterday I told you, right? Map slot and reduce slots. You remember, right? Yesterday I will explain map reduce for 1 or 2 sessions. I will explain what are those map slots, reduce slots, how mapper works, how reducer works. 1-2 sessions. I am not going too deeper into map reduce. Even if you discuss, nobody. Even if I am in the panel, I never ask about map reduce actually. So these are all the things, and few more are what is that? A scheduler, and then application manager. That's all. App manager. Got it, right? These are the core components of yarn here. If you look at this, resource manager has, it's like job tracker. Resource manager is like job tracker. It has 2 components. What is that? Again, inside that you have a scheduler and application manager. Application manager, probably it will take care of application masters. Scheduler allocates resources. What scheduler do? Scheduler allocates resources to all the these machines. Resources for container. Container is like a virtual machine again here. All your what is that? Whenever your node manager should run, this is actually your slave. It will request for containers to run a specific task. Okay, and your task runs inside a containers. Got it, right? That's the point. It's like suppose if you want to cook an idli, you have that idli vessel, right? It's one container, and what do? You put all that inside. What is that? If the whole vessel is one compartment, and that plates, every plate acts as one container, isn't it or not? You put idlis in that plate only, right? Plate acts as container. Without plate, will you put idli into that vessel or that the whole compartment? No. Containers are like plates. And for that, first, what you have to do? You have to allocate CPU, RAM, everything. There are small virtual machines here. Understood? And app master is something which will be talking with resource manager and negotiate resources again. What is that for container? By talking to scheduler. If you are talking to resource manager means what? It means your internal, it has two separate services for resource manager, scheduler and application manager. Scheduler is something which allocate resources for container. All your tasks runs inside container. Understand carefully. Okay. And application manager request for resources to resource manager with actually it will ask scheduler in that resource manager. And scheduler will assign those resources to container. That's what happens. Got it right? And what about node manager? All this, whatever you are seeing, the whole part is part of node manager only. It is a node manager which looks after all this stuff. Okay. So that is the point here. So this container, this app master, everything is part of what is that node manager only. Understood now? And what about application manager? Application manager is something which is used to manage this application masters. Got it right? That is a brief idea. Is that enough for you? Because you don't need too much of this, because even if you learn it out of curiosity, still what is that? There is no guarantee that you are going to use all this. And one more important thing is sometimes might be you can have an excuse as a developer. There are, when you talk about schedulers, for yarn, there will be different types of schedulers like capacity schedulers and pair schedulers. Okay. If you want more information, you can get to this official website. This generally I recommend to go for official documentation, because at least you have some clarity from this official docs. If you go for websites, those people will optimize this. They will just what is that, cut short this data and put you, and you get some idea about something, you don't get some idea about something, you get confused. That's why I always try to bring you to the official documentation directly. Got it right? And you can see here, I have explained now. Who is allocating resources here? Scheduler. Who is taking care of application masters? They are there here. Application manager. And all that is part of what is that? Scheduler and application manager. Both are part of resource manager. But now what is that? There are separate services in that for scheduling and application master management. Okay. Now next one again, your task tracker became node manager, which runs in a separate server, and all these container and application masters are part of node manager. If you want to quickly get some idea, let's walk through this document once quickly, not so deeper. If you see, scheduler is responsible for allocating resources to various running applications subject to failure constraints of capacities, queues, etc. You don't need to understand everything, just understand till this point. It is responsible for allocating resources to various running applications. Point one. This is enough. And everybody can understand this. Okay, scheduler is doing this. It allocates resources. Don't forget about subject to familiar constraints of capacities, queues. This is not necessary for you. Let admin take this headache. Okay, you just understand till this point. So scheduler is pure scheduler. Pure scheduler means what? It will only take care of scheduling. It doesn't do resource allocation as like in job tracker. In sense that it performs no monitoring or tracking of status for the application. I told you, it doesn't. Once it allocate resources, it is done. Okay, it's like a HR in office. You need some budget. It will allocate budget, and HR just keep quiet. Not HR, I'm sorry, the finance department, finance guy. What finance? You want some money. Who will allocate money in an office? The finance guy. But once he gives you the budget, who will track all that, what's happening, whether this is used properly or not? The HR fellow will take care of that. Okay, that's like scheduler is only taking care of resource allocation. And who is taking care of other resources? Then resource manager, application manager will be there, that will be taking care of. Okay, then fine. Next one. It's okay, leave about it. It has pluggable capacity, means we can The services can be integrated, like capacity scheduler or fare scheduler. You can integrate it, not an issue. Okay. Second thing, application manager is responsible for accepting job submissions, negotiating first container for execution, executing the applications, specific application masters. Means I told you in a just quick understanding, application manager manages application masters. What application masters that does here? Application masters request for containers in the node manager. Got it right? What they will do? They will request for containers. Might be you can ask why container. I have explained clearly. It is the container where our tasks are executed. Understood? Earlier, this kind of segregation is not there. Task tracker used to do all that. There will be map slots and uh, reduce slots in task tracker, isn't it? Yes or no? But now that is done by whom? Container. We don't have map and reduce slots. Yeah, only one slot is there. That is a container here. Are you following this or not? We have only one container. No map slot, no reduce slot. If map and slots, reduce slots are idle, then there is no wastage of. There is no such thing like keeping idle or something. Whatever resources that is required to execute a task, only those resources are allocated to container. You got it right? So that's the idea about which one? This yarn here. Understood? That's all guys. I just want to talk about a couple of things here we have discussed. So now instead of task tracker, we have node manager. And then in that we have containers as well as application masters. It's the responsibility of application masters to request for containers. And your jobs are actually executed on containers. And node manager will be monitoring all these services inside slave part. Resource manager has two services, scheduler and application manager. Scheduler takes care of what? Allocating resources. And the application manager manages all the application masters. Name node and resource manager communicate with heartbeat, same like in Hadoop1.x. Understood now? If node manager is not sending heartbeat for resource manager for some time, what happens? Node manager is down. Then resource manager allocates one more new node manager for the existing tasks. Got it right? That's how this works on a high level. Clear, right? Understood now? Is it clear? All of you?
Yes. Yes.
Okay, that's fine. Can I get an yes from all of you once? You can type in the chat box there.
Yes, sir.
Yeah, whatever that is necessary, I have discussed. Still, if you want to dig into that, what do? You can explore this official doc. Okay, you can go. Now we are almost done with this. There is one thing I would like to discuss today. Apart from this, is a difference between. Now you know what else? What are the differences between Hadoop 1x and 2x? Let's get a quick understanding. You already have differences. Okay, in Hadoop 2x, there is no single point of failure. What is that? Here, let me just show you the differences. Limitations of Hadoop 1x are Hadoop 1x. I'll just write here itself Hadoop 2x. It's easy. Already we have some idea there. 1x has one name node, one secondary name node, one job tracker. Here, we don't have a single point of failure. We have a standby name node this time. Standby name node is available. No single point of failure. Understood? And even for secondary name node, you have a standby. I'm not sure on this, but still I assume there is a standby for secondary name node. And then even now the cluster had been, there is a lot of change in service. Earlier we have map reduce, this time we have yarn here. Okay, anyhow, data node has that fault tolerance, but name node doesn't have. Now even name node has a standby this time. A separate standby is available. That is one difference. No single point of failure this time. Right? No single point of a failure. Where in Hadoop 2x. Okay, so that is one difference. Second thing, what happened now? Now you tell me, can you tell the differences, right? What is that? Do we have job tracker in Hadoop 2x? What do we have? Just keep answering now, all of you. Keep answering. If you want to get a bigger picture,
Resources.
what do we have here? Instead of job tracker, we have
And
yarn here. Okay, please type in the chat box. Okay. So we don't have job tracker. We have yarn. Now what yarn is doing? Yarn is replaced with what, gentlemen? With job tracker. And here it has a separate what? Scheduler, source,
and resource management.
scheduler and application manager. What is that? Application app manager, right? Application manager. And here one more thing is there. What is that? Yarn has something called resource manager this time. Resource manager again has what? Two things, two services, scheduler and application manager. And also this time you don't have task tracker. What do we have? Instead of task tracker, you have node manager, and it uses what? Containers.
Containers and that.
There is no point of wasting resources here, because there is something called app master. App master requests whatever that is required, whatever resources required to execute a task. It doesn't waste any resources this time. There is so much optimization of utilization of resources here. Got it, right? So that's the point. Earlier we have maximum number of nodes, 4,000 nodes. Now if it is 2x, okay, we have a scalability up to 10,000 nodes. What is the scalability? We have a scalability max 10,000 nodes. Scalability in Hadoop 2x, folks. Okay, or above, or you can say above also. And here there is a horizontal excuse me, there is horizontal scalability of name. We are adding standby name node, right? Means if we can add additional nodes to the cluster, this is called horizontal scale. But of course not many name nodes, because we don't need those many name nodes in the cluster. Okay, now we have a standby. Still we have that scalability factor is there for name node. So what is that? There is horizontal scalability. We can add additional name nodes in the cluster this time in 2x. And earlier Hadoop 1x is supporting only one processing engine. What is that? MapReduce. But now Hadoop 2x supports yarn. It also supports Spark. Of course, it has Stage. And then we can also integrate Spark. There are so many things which you can blend into this Hadoop 2x. etc. We can still add few more. Okay. And now, okay, sixth one. Earlier, Hadoop 1x supports only what? 1x supports only batch processing, but Hadoop 2x supports Hadoop 2x supports batch as well as it supports batch as well as the streaming. Streaming in sense live data. Okay, streaming. So, but now we have a support for streaming data here. Now this concept, this fixed map reduce slots are replaced with what? Any answer in the chart box? Now we are replacing map and reduce slots with what, folks? Answer in the chart. We are getting these are what is that? We are not utilizing it in a right. Sometimes they might be idle, but now we don't have that. What is that? They are replaced with what? Answer. Type in the chat, folks.
Container.
Exactly. Okay. It is replaced with the container. Got it right? Yes or no, folks? Now map and reduce slots are replaced with what, gentlemen?
Nuts.
Containers. One minute, guys. Okay, next one. Sorry. So it has the containers now, so that resources can be utilized efficiently. Next after that. What is multi-tenancy? Yesterday I told you we'll talk about it today. What is multi-tenancy? One single instance of software running on multiple multiple machines, multiple tenants. Tenant means right, someone who rents your house or something. Isn't it? Is it what we call a tenant or what? Yes or no? Multi-tenancy means one copy of software running on multiple machines is nothing but multi-tenancy. Earlier, this kind of issue is there with 1x, but with 2x, we don't have such issues. Okay, so 2.x supports multi-tenancy. This is not something too deep, but maybe if you want to explore, you can explore it. Got it right? Understood? Or now at some fundamental level, are you guys clear with 1.x and 2.x now? Now you got some clear idea about the basic understanding of Hadoop HDFS, and we have a clear difference here now. We understood the differences between 1x and 2x. Yes, sir. And then we got a clarity like what is that? What is 1x is supporting? What is 2x is supporting? We have all this detailed discussion in this session. Now let me finish the third part also. Hadoop 2x and 3x as well. Okay, let's just discuss quickly. If you look at this, okay, I think I got it some from website there. Okay, so Hadoop 2x and 3x. So this is 2x and this is 3x. 1 minute, guys. So what is this 2x now? What is, we know very well, Hadoop is completely developed in Java. Okay. Earlier, 2x is using Java 7, but 3x is demanding Java 8. And 2x uses replication. What is replication? Block information, like dividing into blocks and storing it as blocks. And 3x is using what? Erasure coding. Now, a sophisticated concept is introduced, which will optimize the block storage. That is called erasure coding. You don't need too much of that. Just get some idea like this. That is what erasure coding is. Earlier, we have a storage scheme 3x. Right? Minimum 3 blocks. One block of data is having 3 replications. So we have a 3x factor for data reliability. There is a 200% overhead. This erasure coding, once this is introduced, it became just 50% overhead. And then overhead means extra burden or extra performance issue. That's what we call overhead. And we have reduced almost 150% of this overhead in 3x. And when you talk about app timeline services, there are scalability issues with timeline services. I don't know exactly, to be honest, what are these timeline services. Maybe Yogesh should help us on this issue if he has some idea. Otherwise, just leave it, nothing to worry on this. This timeline has scalability issues, but now they are scalable and reliable. You know, scalable in sense you can add something extra to that. That is scalable. You have the meaning, right? Earlier we have one standby. I told you, right? We have a standby in 2x. Now Hadoop 3x supports two standby name nodes. And heap management. Heap means it is something where your objects are stored. Earlier they were using what is that? We used to configure Hadoop heap size. You used to allocate memory with this property, this attribute. You know, but now there is an auto tuning of heap itself. You don't need to set it exclusively the size, how much heap size should be there, but there is an automatically this heap size will be grown or reduced automatically. Earlier we have to allocate that heap size. Now that is not there. Automatically the tuning is happening. So if you see, other things are same. The ARM is almost the, I told you, right? We don't have major changes like 1x and 2x. But what changes are there here? There is a bit related to performance. Hadoop 3x has a better performance. It has been more sophisticated. There are so many things tuned here. The optimization had become more. The performance had been grown. That's what 3x is doing here. But same HDFS, same. I mean, the HDFS is same here. That ecosystem. What I mean, there will be changes in the again performances. That is a different thing. Okay, because they were using Java 8 here, then Java 7, and for Hadoop 1x Java 5, I think you can start from Java 5, I hope. Okay, and here again, the ARM concept is almost similar here in 1x and 2x, but difference is there are some differences to timeline services. Okay, and other things anyhow that we can understand here, the scalability factors for name node. There is no single point of failures in 2x or 3x. You got it right now? Is it clear for all of you folks, or any doubts on this? Understood now?
Yes,
This,
yes, Manohar.
this is complete. We have completely discussed, like, all the fundamentals of this. Which one? Your Hadoop, which is related to the which environment? Your cluster environment. So okay. So if anything is there, we can keep discussing when the topic is going on. Now tomorrow, what we have to do is we should plan to install. What is that we should install? We should install this Cloudera distribution. What is that we should install? Cloudera distribution, and then start working on it. And now in the market, so that is fine. Now I'll quickly explain the other ecosystems. You have clarity here, right? I have finished discussing this. There are other ecosystems. Now we know about HDFS and we know about MapReduce. What is MapReduce, folks? Can you answer in the chat box? I'm waiting for your answer. What MapReduce does? I got just one answer out of 22. At least 2-3 answers will be reasonably good.
It will do processing.
Processing the data.
Exactly, processing data. Next one. Now you know what is AND here? What AND does?
It will do the resource management.
Same processing engine. Difference is it has a what it has a it has a segregated approach of handling services. Okay, where job tracker don't have, which is part of MapReduce. That is difference. Now what is Hive then? Let me start quickly. What is Hive? I'll give a quick idea about Hive now. So let me explain ecosystem by ecosystem. A brief introduction to all ecosystems quickly, whichever are very popular. Not you don't need to get idea about everything. So when you talk about Hive here, let me explain this. Actually, Hive is a data warehouse. No? What do you mean by data warehouse? Usually we perform more of there is something called OLTP, OLAP, OLTP. Okay, and one more is a OLAP. Now, what are these differences? If you talk about data warehouse people like Informatica, data stage, these people, when you talk to them, they are familiar with they talk more about OLAP. If you go and talk to DBS like Oracle DBA, SQL Server DBA, they talk about OLTP. What is this difference? Simple, folks. OLTP is something called online transaction processing. This is online analytical processing. So here, what is difference here? We perform all the crude operations here. What is that we do? We perform all crude operations. What is that? We perform read operation, write operation, and then what else we have discussed? What else? Usually, when you talk about a database, we have all this. What do we have? We have insert, we have update, and then we have delete, and we have what is that? Select. Okay. All this what we call, when you include all this, more than all this, if you are able to do update and delete, okay, all this insert, no, this is called transaction management processing. You got it right. So that is OLTP. OLTP means it performs all this. They perform write and read operations. Right, in sense, insertion is a write operation, update is a write operation, even delete is a write operation. Means because if you delete something, it has to modify the table. Select is only read operation. That's what OLTP does. It does all these operations. OLAP means it will mostly perform read operations. Online analytical processing. What it does here? It takes care of analysis. So here, which is very important, selection is very important, more than insert or update or delete, which is important here. Selection. That's why in Hadoop, in Hive, we cannot update directly, we cannot delete directly. Even insertion is not direct, like how you do in Oracle or like that. It's not possible to directly delete anything. Row by row insertion, row by row deletion, row by row updates. Such kind of thing is not there in Hadoop. Of course, in Hive you can do that, but in a different way. We'll talk on this when we switch to Hadoop. So what OLAP tools does? They focus more on reading data. Yes,
Manohar,
yes.
can you remove mute? Actually, I'm getting frequent message like
Which one? Sorry, what's happening?
I'm getting frequent messages saying that organizer muted, something like that. I'm not sure.
But still, it's not. I didn't mute anything here. Who is that?
I'm Suresh.
Suresh, there is no mute happened here. I don't know why.
The organizer muted, I'm not sure exactly. That's what.
Can you hear me now? Hello.
Yes.
But still, I never muted. But for others, anybody has that issue? Not sure because.
No, we don't have any issue. I think he has some network issue.
Okay, that should be the reason. I see some of the folks having some network issues.
No, I think like he might be closer to mic and trying to speak something. So that time it will give those kind of message like you are muted by organizer or something.
Okay, okay. That's fine. I understand that. But I once we start, mostly we don't mute. If it is muting, I know here. Okay, right. So that's fine. So here I am talking about something. So still, OLAP analytical processing means it performs more read operation because you try to extract so much of data and try to do analysis on that and do some what is that reporting on that or some predictions on that. This data warehouse people are the even Hive. The purpose of Hive is it acts as a data warehouse where it is used to store data. Then what is that? It's like less write operation, less writes, more reads. Once you write once and read many times. That's what this follow here. Like in a traditional RDBMS, you keep updating the data frequently, very frequently. But Hive is not like that. Hive is to store like periodical data. The changes happens not that frequent compared to which one your RDBMS. It's more for what is that Hive purpose is. It's used for doing some analysis on data. Once you put data into the Hive, what people does is the other usually the other teams like the data science teams, sometimes Hadoop is connected to other areas like data science or like API, like that. What it does is, as a big data engineer, you keep data ready for others. Data ready in sense you don't do too much of database programming here, like how database administrators do. Again, that is not there. This is includes everything. You are master of all. So sorry, you are jack of all. You are master in some areas, not every area. Again, if you ask me, I'm a master of everything. If you are a master of everything, it's good for you. But you will be master in certain areas. That is fine. I know that. I can tell that. And this is what OLAP is. Got it right? It's more for it performs more reads because it is used for analysis, as the name says, analytical processing. Okay, so that is the difference now. Maybe if you want to get a deeper meaning of this, you can quickly try this. And Hadoop, this Hive is what, folks? Hive is a warehouse. It is not a database. And generally, warehouse follows OLAP. They don't follow OLTP. Still, we have issues in updating and deleting and inserting in Hadoop. So it's mostly used to perform analysis. It's more recommended for more reads than writes. But still, of course, we can keep data. We don't have issue. But data is kept as a file itself. We directly load files into the Hive. We don't load data like in RDBMS, like row by row or column by column. We don't do that in Hives because this Hive is used to load. It is used to hold huge volumes of data. So GBs of data. You can directly put 1 GB of file to Hive, or 2 GBs or 10 GBs of data to the Hive directly. You try to load it directly. Got it right. Once after loading, you do certain operations on that data. Again, you do some cleaning or you do some kind of processing like that. Cleaning in sense removing spaces, removing nulls, and observing the data types, any changes required to that. All these parts calls, we call it as a cleaning of data. So there will be again, when you put it data here in Hive, all these things happen, folks. What is that? Storage of data. Second, that is one thing, and second thing is again we do cleaning on top of that data. Again, what is that? There will be temporary tables, like staging tables, what we call in Hive actually. Staging means from stage 1 you have a raw data. You directly load a file, and on top of that again you filter that data, clean that data. That is stage 2. And on top of that again you do some transformations on that data. That is stage 3. This is how data goes. And finally, once everything is structured, then you will move to the RDBMS. That's how this works. Got it right? This point is very interesting actually. And this is what actually Hadoop engineering at every, see again there is again there are different things. Not you don't work in every layer. Suppose if you are doing cleaning, you don't work into some other, because earlier, let me tell you one more thing. As I am talking about Hive, let me give a clear picture here itself. It is more of OLAP again. OLAP in sense more for it is recommended more for reads more than writes. It is used for more for analysis. It does a transaction management, all this. Okay, insert, update, delete. When you include all this, this is part of transaction management. OLAP generally takes care of what read operations. For getting a clear idea, I'll just show you here OLTP versus, because let's have a detailed analysis. OLAP. Okay, just a difference, quick difference. Anywhere is fine. Just have a quick difference. The basic definition is enough for us. We don't need to go too deeper into what is that. Modifying system, you can see here. Database where OLAP is querying. Querying means mostly you do selections. Okay. So you can see now. Generally, when you say transactions, what is the transactions involves here? They involves insert, update, and delete. And here, querying in sense, mostly you do what? You try to perform just selections here. I'm just looking for actually, you can see this. This is very clear. So here, OLTP is an online transaction processing system. The main focus of OLTP system is to record the current, update, insert, and deletion. Just now we had a discussion. Okay, OLTP requires are OLTP queries are simpler, short, and hence require less time in processing and also require less space. Got it right? This definition is enough for us. Okay, you don't read everything. Sometimes you need to just focus on what the core point. Other things anyhow that you want. Now let's talk about this. OLAP is online analytical processing system. What it does, as I had discussed, OLAP database stores historical data, periodical data. That's what it is. That has been inputted by OLTP. See, who will write data to this OLAP? By OLTP means you copy data from other data source. Other data source is some other database, or you directly put a file into that. Okay, it allows users to view different summaries of multi-dimensional data. Summary in sense you do selections. All of you know idea about select operation, right? Using OLAP, you can extract means selection. I told you this is clear. Information from large database and analyze it for decision making. This is what OLAP is. Here, what you are missing here, you are missing inserts, updates, and deletes here. What you are focusing here, you're trying to extract data, do the selections, and get that data and do some analysis. That's what makes some report. You got this clearly? Okay, that's what this is. And Hive is all about that. We'll discuss Hive again. It is a separate ecosystem. I'm just giving a quick and brief idea. We are not done with this. Don't expect too much in one session. Either if I try to talk everything in one session, either you will go hangover. There is a hangover, right? When you have that, when you go and drink some, what is that? When you consume some drink, you have some of you at least have experienced out of 20, at least one of two have faced that issue. I'm sure of that. If I teach everything in one session, then there will be a hangover. That headache will start. Don't take that headache now. Just get a quick idea. Enough. That is Hive guys. What's some idea? It's a warehouse. Why do we use it? It is used for more for OLAP. It's more for doing the analysis, and you put data in the form of files there, or you can directly load data to Hive through different data source from a structured database like Oracle. Got it right? Like that. We'll talk more on this. Then other important thing here is HBase. It's a database, and we work mostly with this HBase. Okay, every day we have, because that is what our storage this thing is. So we store data in HBase. We don't store in Hive. Sometimes both will be there, but fortunately and unfortunately we don't have Hive. It doesn't mean that earlier even the previous project don't have Hive, but might be in the next project I might work with Hive. Got it right? What is HBase here? HBase is this is called NoSQL database. Database fine. What kind of database is this? NoSQL. And I really like HBase, because as I'm seeing it every day, the way you store data, the way you extract data, the way you manage data is totally different from Hive or this RDBMS databases. Okay, where here NoSQL means these are all columnar databases. What is that? Columnar databases means your data is stored in the form of columns. I'm quickly giving you brief idea. in the form of columns. Okay, what is that? If you want to see that, we'll talk, at least for HBase, we'll spend at least a week time. For Hive, at least we spend 1 week time or more than that as well. So when you are more than 1 week, we'll talk on HBase. And when we are discussing that, I'll explain the architecture of Hive and everything, and then we do the queries. And we work on different scenarios of the indexing and as well as that there are many other things, the bucketing concept in Hive. We'll talk about all that. Even in HBase, we see how to store it, how to write data to HBase, read, and how to do some querying. The advantage is this time I can share my real-time knowledge, like working knowledge on HBase, like how to prepare your queries, how to search it, how to write some automation codes like with Python. If you are interested, I can show you that also, because we do certain automations. So I can help you to do at a deeper level of everything. Got it right? So in the follow, the advantage is you have high throughput here. Why people use HBase? Many people don't know. Because the performance wise, these NoSQL databases are very good. They provide the best performance, so that what is that, and there will be dynamic processing here, dynamic extraction. You can read data. Reads become more faster here. Read in sense getting data. It become more faster in HBases comparative to Hive or comparative to RDBMS. But these are all part of. These are all built. One point I missed here is Hive or HBase. These are all built on top of HDFS again. So this is built on top of what? On top of HDFS. These are all part of HDFS. Even HBase is built on top of HDFS. Okay, it is built on top of HDFS. That is one more thing. Got it right? So we'll talk more about it. Okay. So still there are few more ecosystems like MapReduce. I'll just quickly tell what is MapReduce in tomorrow's session. And then also I will introduce other things, other important. We will also just quickly get introduced to Spark and also we try to understand few more ecosystems here like Oozie. What is Oozie? What is Flume? What is Zookeeper? And what is Scoop? Okay, what is Peak? Tomorrow I'll just introduce what was all this. Just a brief discussion. What is what? Something what we call. Then I'll switch to, then I'll explain like how to install Cloudera distribution in your local machines. And later on, we have two things here while practicing, either CloudX Lab. Those who don't have that 8 GB RAM or 16 GB RAM, so you can go and go for CloudX Lab. That is one thing. I don't know who's this actually, but usually what I see is if you don't have sufficient resources to manage that practice, this is one of the best resource. That is one thing. And otherwise, if you have that sufficient RAM, everything, then you can go for Cloudera Manager distribution. Cloudera distribution. We work on distribution, Cloudera distribution now. Even Hortonworks is bought by Cloudera. Means in a way, what is that? You don't need to worry about Hortonworks or Cloudera. Both are under one umbrella now. In future, both get merged and you get a single virtual machine again, like earlier, single distribution in future, not now, immediately. That's how it goes. So already I have explained this, how to connect it to CloudX Lab, how to register yourself to CloudX, and how to start working on that. That all the videos are uploaded into the YouTube channel last night. Okay, so you can go and try this. Try in this channel like Manohar. Learn well. Okay. If possible, please share these videos to your friends. These are really useful. I am telling you because I am the teacher. That's not why I am teaching. I am trying to tell this point. But the depth of the subject is very useful to working people as well as learners. Second thing is, this is our website. If anybody wish to register and get updates, I told you right, you can register here, manoharpapasani.com. This is my website. So you can go and enroll in this. You can suggest to your friends as well. I thought to tell you this about the resources. Okay. So you can register here. Okay, that's fine. That's all, guys. So tomorrow we'll continue with the rest of the discussions. Okay. Any more questions after this? So finally, what is the conclusion part here? What else? We have got a clear idea about all the essential things of HDFS. Tomorrow I'll finish all this ecosystems brief discussion, and then we'll figure out which topic to start. Okay. Either should we start with the most happening, the high priority concepts, and then we switch to the next one, or shall we go with some other order? We'll see it in tomorrow's session. Then we'll plan according to that. Again, I am telling these sessions are completely free, and we are not going to stop here. Okay. So we'll have a complete details on the course, and the course is going to be, almost for 3 months, and then the detailed discussion happens. And we are not going to charge anything. There is no, because some people ask me after 1 month how much you charge, after 2 months. There is no point like that, guys. I don't usually. You can attend my free Python sessions on weekend as well. You can that, but we don't have any charges. Okay, right. If you have any such doubts, you don't have to keep any such doubts there. Keep attending, keep learning. So if these sessions were useful to you, just share with your friends. That's what I request. Any questions apart from this? No, we are done with this today's discussion. I have another session after this. Any questions?
No from my side.
Okay, others? Others? After that also it will be good, Srikanth.
Definitely, sir.
Okay. Okay. Good so far means till the end it will be good.
Yeah, correct.
What else? Anybody has any questions like Madhu or okay. Okay, guys, we'll meet tomorrow. Tomorrow we'll talk more on about all this and stop there. Thank you.
Thank you.